Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today we're diving deep into the fascinating world of cloud virtualization, specifically exploring the internal architectures of Red Hat, AWS Firecracker, Ubicloud, and AWS Nitro. It's a complex topic, but we'll break it down step by step. Ready?
Absolutely. I've always been curious about the underlying mechanisms. So what's the core challenge this blog post addresses?
Exactly. The core challenge is the increasing complexity of understanding modern VM technology. It's not just about one component. It's a complex interplay of dozens of Linux projects working together to achieve operational and security isolation across CPU, memory, disk, and network. Think of it like a finely tuned orchestra. Each instrument, project, plays its part, but the conductor, the overall architecture, is crucial.
Right, and that's why this blog post is so valuable. It's essentially a deep dive into these architectures, right?
Precisely. They analyze 4 key reference architectures. Let's start with Red Hat. Their approach relies heavily on KVM, QEMU, and libvirt. KVM provides the core virtualization infrastructure within the kernel, leveraging hardware virtualization features like Intel VTX or AMD. QEMU acts as both a device emulator and VMM, handling the interaction with the guest OS. And libvirt, in Red Hat's implementation, acts as a jailer, enhancing security by confining the QEMU process.
So QEMU is the key player here, emulating hardware and managing VMs. But what about isolation? How does Red Hat handle that?
Good question. Red Hat uses cgroups for operational isolation, limiting resource usage for groups of processes. For security isolation, they rely on Linux network namespaces and ccomp-BPF, though these aren't explicitly detailed in their reference architecture. Interesting, huh?
Now let's move on to AWS Firecracker. I understand it's designed for serverless workloads. What makes it different?
Firecracker takes a different approach, prioritizing lightweight design and security. While it uses KVM, it replaces QEMU with a custom VMM written in Rust. This significantly reduces overhead and attack surface. They also use Virtio for device emulation, which is a great choice for its simplicity and performance. Security is further enhanced through network namespaces and ccomp-BPF, creating a very secure sandbox for each micro VM.
So Rust's memory safety is a key advantage here, minimizing vulnerabilities. What about Ubicloud? How does their architecture compare?
Ubicloud's architecture shares similarities with Firecracker, also prioritizing security and simplicity. They use KVM and the Cloud Hypervisor, CH, which is largely based on Firecracker but offers more general-purpose capabilities. Like Firecracker, they leverage Virtio, network namespaces, and ccomp-BPF for isolation. However, they use SSH instead of REST APIs for communication between the control and data planes. A fascinating choice.
Interesting. And finally, AWS Nitro. This seems to be a more hardware-focused approach, right?
Exactly. AWS Nitro represents a significant evolution, offloading much of the virtualization workload to specialized hardware accelerators. This dramatically improves performance, especially for I/O-bound tasks. By offloading device management and VM monitoring to hardware, they reduce the reliance on a heavyweight VMM like QEMU, resulting in a more efficient and performant system. A truly impressive feat of engineering.
So in essence, we've seen a progression from software-heavy virtualization to a more hardware-accelerated approach, each with its own strengths and weaknesses. This blog post provides a really valuable comparison.
Absolutely. It highlights the evolution of cloud virtualization, the trade-offs involved in different architectural choices, and the crucial role of open-source projects in driving innovation. And remember, the blog also emphasizes the growing importance of security and the need for robust isolation mechanisms in modern cloud environments. A must-read for anyone working in this space.
Definitely. Thanks for breaking this down for us.
My pleasure. And to our listeners, thank you for joining us on Tech Bytes and News. We hope you found this discussion insightful. Have a great day, and we'll catch you next time.
Bye-bye.